Hello, everyone, and welcome to week 12 of an introduction to agent-based modeling. I'm sorry, I'm running a little behind this week, so I didn't get your normal email out to tell you about it, but I'll send it out shortly after this video goes live, so we'll talk about the details there. But the big thing is that of course, we're in the process. Everyone's got their final projects turned in, hopefully. That was supposed to be done last week. And now we're in the final phases where we're doing the peer review, right? And then the other thing we're working on is Unit 9. And a couple of people have pointed out Unit 9.3 to the end, which is 3, 4, 5, 6, are not up yet. And the reason why I've been holding off on those is because I've been waiting to get 9.3 finished because it was incorrect, because the way the functions that are talked about in 9.3 are done is different in NetLogo 6 versus NetLogo 5. Anyways, long story short, I am wrapping those up today. They will be up online today. And so partially, in order to give you more time, because normally the class was supposed to end on August 31st, I am going to extend the deadline for the class, not for the peer reviews, but for the class itself, by a few days. I have to look at the calendar to see exactly what deadline the new deadline will be. But that will give you time to work through Unit 9 and the Unit 9 test. So I apologize that it is totally on my fault. It's just been a little crazy around here at the start of, because our semester started for the school. So it's been hard for me to get everything kind of done. I was hoping to have all this stuff wrapped up before the semester started. And so I apologize for that. Anyways. I will get it up online as soon as possible. I'll extend the deadline. That's my kind of remediation. If you have any questions or concerns, please let me know. And I think that's it, right? So the next 2 weeks, basically what you're doing, a week and a half by now, right? Plus whatever we wind up tacking on. You're working through Unit 9, and you are also working... doing the peer reviews. So if you have any problems with either of those, let us know. And with that, let me get on to the regular office hours. By the way, again, as always, if anyone has a question, feel free to ask it on the YouTube live chat. You can also tweet at me, and I'll try and pick up a couple of emails and other things. Oh, that reminds me. One big thing that came up is that the Complexity Explorer website was down for about a day. That's another reason why I'm planning to extend the Unit 9 section, because I know some people only do things on certain days. So, like I said, I need to take a look at the calendars, get the date exactly right. I'll probably announce it in the email that I'll be sending out shortly. But you'll look forward to seeing those, and you will have a few extra days to finish up Unit 9 and whatever other materials you haven't done in the textbook. Okay, so or in the coursework, right? So, let me see. Pull up this. I'm just pulling up my notes real quick, so I can answer any other questions that came along. Okay. Okay. Oh, so there's been a couple of questions about making models available, right? And after peer review is closed. And so Gabby, who's one of the administrators for the Complexity Explorer, is going to collect the links. Basically, the easiest way for us to do this is for you to upload the model to the NetLogo modeling library, right? And then post the link to it, or send the link to abm@complexityexplorer.org, or admin. Actually, it's probably easier to send it to admin@complexityexplorer.org, and then Gabby will make sure that there's a collection of links that are put together. So anyways, so let me know if you're interested in making those available. There's been a couple questions about that. If you are, then go ahead and email to admin@complexityexplorer.org. Okay. one other question that's come up. A couple people have had questions about questions on the exams. Obviously, we don't want to discuss those in the forum, but if you have a question about them, please email abm@complexity-explorer.org. If any questions you have about the exam, right? Um, and then I can look into it and see if there's any concerns. There was a weird one that came up recently. It's not on the exam, so it doesn't matter too much. But on one of the quizzes where I think one of the quizzes got out of order this year, and so it was in a different place. I'm going to look into that, make sure that's fixed for next year. But hopefully that didn't bother you too much. It was 7.1 and 2. I think the wrong quiz was in the wrong place. But anyways, long story short, I'm going to look into it and try to fix it for next year. Regardless, if you ever run into any problems like that, let me know, and I am happy to look into it for you. Okay. I think that's most of the major questions that came up this time. Yeah, 7.1 was the quiz. Oh, there was an interesting discussion I wanted to talk about the termites. So the way the termite model worked, which we looked at in the in the unit 8, right? And let me bring it up real quick. All right, it's probably the best way to do it. So for those of you who know something about computer programming, there's this concept known as recursion. And what recursion is this idea that the function calls itself, right? And that's fine as long as there's what we call a bottom to the recursion, right? And what we mean by a bottom is a spot at which the function will stop calling itself, right? Because if it calls itself constantly, an infinite number of times, right, then it's going to run the computer out of memory eventually, right? So in the termite model, try to bring it up real quick. There is an example of recursion. Okay. Oh, that's getting too big. The laptop camera. Okay. And so you're not going to see what I'm doing, but I'm pulling up the NetLogo termites model. Termites. Okay. So if you look at the code here, right, and we go down to search for chip, right, you'll notice that the code says if color equals yellow, then set color to black, set my color to orange, set the patch color to black, set my color to orange, go forward 20. Otherwise, wiggle and search for chip. So this is an example of recursion because search for chip is still calling search for chip. Now there is a bottom to this, right? The bottom of the recursion stack is this part right here where it says if the patch color is yellow, then don't recurse, essentially, right? And so, let's not close it. Don't recurse. And so what's going to happen, right, is as soon as that happens, so when the color is not yellow, right, when it's black, for instance, right, it's going the bug is going to wiggle, the termite's going to wiggle, and it's going to run search for chip again, right? And wiggle, by the way, just to remind everyone, is just right random 50, left random 50, forward 1, right? And so it's just kind of wiggling along, right? And it's going to keep calling this. Now, as soon as it hits a patch that's yellow, it's going to exit the last instantiation of search for chip and then go back to this right here in the code, right? But as you can see, there's nothing after this in the code. So it's going to end that one, and it's going to go back to the next instantiation, and so forth. And it's going to go out all the recursive stacks. Now, the discussion was made in the forums, right? What stops it from going too deep, right? Well, first of all, you got to remember, the termites don't actually destroy the yellow chips, right? They just put it someplace else, right? And so it is possible that this recursion stack could get quite deep, right? And you can actually do that. You could set up counters to count how deep the recursion stack goes, right? But it doesn't happen in practicality many times because eventually every termite finds a chip, right? In fact, Sean Doherty did some experiments, and he put the density of chips down to 0, right? Which means there's no chips, right? So if you go over here and you put the density on this slider down to 0, then there's no chips, and the model will eventually break, essentially, because it'll get the recursive stack so deep. And Sean said he found that when about 60,000 recursive stacks had happened, right? So that's pretty far down into the model, right? Now, he also mentioned that he did some experiments and he found that on average with normal settings like 420%, right, that the model only went down about 400 level recursions at its deepest settings, right? Still pretty deep, but it's not deep enough. You got to remember, the other thing about recursion is how much memory is that particular section taking up, right? And if it's not a lot of memory, then it's simply not going to cause that much of a problem. And the state that's being recorded here is very small because there's very small changes in the overall state of the system. So it's not going to be as big of a problem, right? Anyways, so yeah, so that is kind of how recursion happens. And if you didn't understand exactly what was being discussed there, it's actually a fairly advanced computer concept that can be used for some really cool math, actually, which the Termite Model is not a great example of, but the Termite Model is an example of how to use recursion to solve quick problems easily. So, let's see. Then there were a bunch of questions, and these I think were all. Yeah, we discussed most of these already, or similar versions of them before, so I'm going to leave it alone. But there were a bunch of questions on, about how to check changes in the system, right? And the simple answer is that, there is not a lot of built-in NetLogo monitors for things like checking the state of agents and stuff like that. Instead, you have to build those, right? So one way to do it, right? Like Bruno wanted to know how to check how many times a patch had changed, right? Well, the way I would do that is I would add a patch's own variable that let's see, we can do it real quick. I think in the termites model. So there is no patch's own variable here, right? But we can add a patch's own changes, right? So this is just going to count how many times the patch goes from being a wood chip to not a wood chip, essentially, is the idea, right? And then I would find every instance. Well, the first thing I would do is make sure that my changes variable, which I just created, is set to 0 in the beginning of the world, right? And then I would find every place after the initial. So let's assume that the world is what it is at the beginning, and so we're not going to change it right then. I'm going to find every place after that, and I'm going to do that by searching, right? So I'm adding in, just so you see it, right? I'm adding in the search bar. All right, so I've got my little search bar here running, right? And so now I see the p color equals yellow, set p color black, etc. So I can set changes to changes +1 right there, right? And this will say that this patch has now changed, so I'm going to check it. And then then I say if p color does not equals yellow, we go find new pile, right? That's not really, that's just checking the status. That's not changing it. But then here we're going to change it again here, back to a yellow one, right? And that should be it, right? Because all we do is we change from yellow to black. So those are the two types of changes. So once we've done that, right, now I can close out my find window. Right. Once we've done that, now we can hit set up and go and let the model run. And we can quickly see, is this actually doing, so we can print changes of patches, right? And as you can see, most of them are still 0. Most of them haven't changed, but there are some that have now changed, right? And we can actually see, for instance, what's the maximum any of them have changed. And one of them was changed 4 times. If you wanted to get that exact one, you could say inspect max one of changes patches. Oh, did the wrong way around. Max one of patches changes. Right, and so it's this patch right here, -19. Oh, sorry. I'll highlight it on here, right? So it's just the watch me button on the inspector. You can't see the inspector. I can show it to you real quick. Interesting. Where did it go? Doesn't seem to want to show the inspect. That's interesting. Huh. Not sure what's wrong, but for some reason, my streaming software won't let me show the inspector window. So that is what it is. Oh well. So I can't show that one, but you can see the patch, right? It's highlighted up here, and you can look at it. Anyways, just quick kind of comment on how to track things like changes. Related to that, Bruno also had a comment about a lot of times in our code, we'll do something like what is in the Termite's code, where we say, if random float 100 is less than density, set p color yellow, right? This is going to randomly assign some of them, and so if you hit setup, right, and let's make it 20% just to make it obvious, right? And if I look at my world, so this is a 201 by 201 world. Right, so 201 by 201 means there's 40,401 patches. So if a density of 20%, then at the beginning of the world, 80 of them should roughly be yellow, right? So let's hit setup, and let's say count patches with p color equals yellow. And so on 8245, right? And here 8111, 8030, right? And so they're all around it, but they're not exactly 20%, right? So what if I wanted to make exactly 20% yellow, right? Well, then there's a simple thing I could do. I could go into my Termite's code, and instead of saying if random float 100 is less than density, set p color equals yellow, I could say ask n of and let's do density times count patches. And wait a second. Density is in percentage, so I gotta do density divided by 100 times count patches. Actually, and I'm gonna want to move this outside of the ask patches, because this is where I'm asking all of them. So ask n of density divided by 100. So that's going to be 20 divided by 100, which is 0.2, times count patches, which is that 40,000 number. Set p color equals yellow. All right. So now what this is going to do is going to still choose a random set, but it's going to set expected number and a list or ages. Oh yeah. Now that seems kind of weird there, but what's going on? Let me put some parens in so it makes it more obvious. Right, so what we're saying is take this density number, which is 20, divide by 100, and then multiply times the count of patches, and then I want n of whatever that number is, patches, to set their p color equal to yellow. Right? Okay. So hit setup, and now if we do show count patches, it's 80, right, which is exactly every single time, right? But it's still a random configuration. And Bruno was asking, well, what if I want to do multiple colors, right? Well, as long as, and we should probably do this at the beginning, ask patches set p color equal black. Now, we know that the default is black, but just in case, right, we can do that. And now what's interesting is we can now say ask patches. Let's say that we want to make 50% of them green, right? That's something other than a wood chip, right? But not empty. We can say ask n of density divided by 100, whatever, and this could be our green density. It doesn't have to be the same one, right? Patches with p color equals black, right? So the nice thing is here is now we're asking a completely different set of patches, 20% of the ones that are left, right? To set, well, actually not 20% of the ones that are left because the number is still the same. It's still the count of total patches. But we're going to set 20% of them to yellow, and then we can set another 20% to green. So now you'll see that if we show count patch to yellow, 80-80. If we show count patch to green, 80-80 as well, right? So this is a way you can kind of continue to do this, and you can continue to set like 20% to red, 20% to green, 20% to yellow, etc. And the only problem with doing this is you got to make sure at all times when you're assigning things in this way. The nice thing is if you do it randomly, right? Then in the way that this model was originally doing, then even when you change the world size, right, it doesn't matter too much. And in fact, the code I just wrote doesn't matter too much about the patches. The one thing it could matter, right, is you have to make sure your percentages are always less than 100, right? So if you said ask 30% to be green, 40% to be yellow, and 40% to be red, right, that's not going to work. And that last one is actually going to cause you an error because there's going to be not enough left, right? So it'll cause you a problem there. Okay. Other than that, let's see if there's any other questions there. Okay, let's look through this. So some people have had problems, by the way, with the attachments on the model design review. One had a problem where the info tab was in Spanish and they didn't speak Spanish, obviously. We do ask that you upload all your assignments in English just because it makes it, because we have people from all over the world working on this course, and so we can't review your assignment if it's not in English very easily. And that's just, we choose English because it's the default, not because of any other particular reasons for it. It's the most widely understood of the languages that we're working with. We also had something where people had problems with the zipped attachments that they're sending. That happens. Let us know. Email us if the zips aren't working for some reason, and we'll try and look into it on our end. Let's see. Yeah, and this, by the way, this is the first year that we've done the additional attachments, right? So hopefully you guys are helping us debug it. Let us know if you're running any problems. And then, of course, some people had some problems with not being able to access the website. And I had a couple of people who mentioned that some of the assignments do seem to be direct copies of models already attached. Thanks for letting us know on those. We'll definitely look into them more on our end. Okay. And then some people have had some problems with not getting new assignments necessarily to peer review. We can usually fix that. So if you get a bad assignment, if the assignment you get you can't do a peer review on for whatever reason, right? Like it's just not opening or whatever, right? Email us. Probably the quickest way is to email admin@complexityexplorer.org. We can force it over to another peer review assignment for you, right? And so that should solve that one. Okay, I think that's all the questions that have kind of come in since the last time we chatted. If there are any others, let me see. I'm just checking out the Twitter feed, but everything else should be right on track. Oh, I saw some great, actually I got some great news from some people who have actually published their models up on Modeling Commons. That's fantastic. Definitely awesome. Thank you very much for doing that. And got some great news actually from a student from last year. This is awesome, by the way. So a student from last year reached out to me that their model that they did as their final project is actually now a full paper that they are submitting. It's not published yet to my knowledge, but as soon as it is published, I will definitely let everyone know, because that'll be awesome. That'll be the first model from this class that has become a scientific publication, right? So when that happens, I will definitely let you all know. But anyways, they're apparently in the process of getting it reviewed at this point. So probably won't happen before this class ends, unfortunately. But next year we'll have some really good news this year. Okay, so that's it as far as I can tell. If you have any questions or concerns about the peer review process, let me know. Otherwise, I will talk to you all next week. And next week may or may not be my final office hour. It depends upon how far I wound up extending the class. I promised to do a final office hour in that last week if we extend the deadline past that. If I can. I have to look at my schedule, but I will do my best. Thanks, everybody. Good luck with the peer review assignments, and let me know if you have any questions. So, yeah, just to recapitulate, you're working on peer review assignments in Unit 9 this week. Okay? Take care. Bye.